The Proctor compaction test determines the greatest unit weight that a certain type of soil can be compacted to by employing a controlled compactive force at an ideal water content. All engineered compacted soil placements for embankments, pavements, and structural fields are based on this soil test, which is the most common laboratory soil test. To establish the level of soil density, in-place measured densities of the compacted fill are compared to the findings of the Proctor test. The objectives of this experiment is to determine the relationship between the moisture content and the density of the soil. The materials and apparatus needed are the following: a cylindrical metal mold, rammer, sensitive balance, thermostatically controlled oven, steel straight edge, moisture containers, sieve, scoop and tray, graduated cylinder, and mixing tools like a trowel, spoon, and etc.
Gather 3 kg sample of dirt. The sample must still weigh 3 kg after air drying. Typically, this soil will be finely ground and pass through a 4.75 mm sieve. If the soil is coarse-grained, add water until its water content is just about 4%. Water is added to fine-grained soil to get its water content up to 8%. After addition, the sample's water content must be lower than the ideal water content. After adding water, the soil should be mixed thoroughly before being covered with a damp cloth. This sample is set aside for the maturation process for 15 to 30 minutes. The apparatus is then prepared by thoroughly cleaning the mold. The mold needs to be lightly oiled and dried. Weigh the mass of the mold with the base plate and without the collar.
The mold is then placed on a solid plate, and 1/3 of the mold's height is filled with prepared mastered soil. This layer will be struck with the rammer 25 times. The rammer has 310 mm freefall height. Note, if a larger mold is utilized, there will be 56 blows for each layer. Here, the mold's capacity is 2,250 milliliters. The compaction must be done in such a way that the blows are evenly distributed over the surface of each layer. Next, add the second layer on top. The top of the first layer needs to be scratched before the second layer is added. At this point, 2/3 of the mold's height has been filled with soil, and 25 strikes are used to compact this as well.
For the eighth step, the third layer is added. It is compacted through a similar process. The final layer must be projected outside the mold and into the collar. This amount must not exceed 6 millimeters. Next, rotate the collar to break the link that is holding the soil in place found in the mold. The collar is then taken off and the topmost layer of soil is leveled and trimmed to the top layer of the mold. Next, the mass of the mold with compacted soil and base plate is determined. Hence, the mass of the compacted soil is determined as the mass of the compacted soil is equal to the mass of the mold with compacted soil and base plate minus the mass of the mold and the base plate itself.
The bulk soil density is determined by the volume of the mold and the mass of compacted soil. For the used water content, the dry density can be calculated from the bulk density. Repeat the experiment procedure number 1 to 8, increasing the water content in the soil by 2 to 3%. Each test will provide a different set of values of water content and dry density of soil. From the values obtained, the compaction curve is graphed between the dry density and water content.